the locks based on innovative hydraulic designs. And the water-saving basins, the largest in the world, will reuse about 60% of the fresh water consumed for lock operations. State-of-the-art analysis techniques will ensure that lock wall configurations meet very stringent seismic criteria. The lock wall designs incorporate drains that reduce the static and the dynamic loads on the walls, reducing their section and size, while achieving the required performance goals related to deflection and durability. The lock gates are sliding versus the miter gates that exist in the current canal and are arranged in pairs for safety. The length of the locks account for the length of the ships plus the tugboat that will be used to tow the ships through the locks. The design for the filling and emptying system was approved in February of this year, 2011, following a series of tests on the physical model. The design specifications call for savings in reusing approximately 60% of the fresh water used in the lock system. This is an important advancement in a country eager to conserve its freshwater resources.
New locks will be larger but use less water than the existing locks. Basins next to the new locks will recycle water from the locks as they are emptied and use it to partially refill them when another ship comes through.
Nearby basins will recycle the water from the locks as they are emptied and use the water to partially fill the locks when another ship passes through. Water from the canal's lakes will also be used to fill the locks.
Water-saving basins are one of the most important and challenging aspects of the design. Here's why.
The chambers of these new locks have 427 meters of usable length when both guarding gates are closed, with a width of 55 meters and a depth of 18.3 meters. These new dimensions will initially allow the transit of vessels of up to 366 meters in length, 49 meters in beam, and a maximum draft of 15 meters in tropical freshwater, with a line of vertical fenders every 15.2 meters, and they're illuminated by high-mast sliding lamps, which allow a safe passage through the locks at night. Each lock chamber will have 3 water-saving basins, which will enable using 7% less water than the existing lock system, reusing 60% of the water required for each transit. Each water-saving basin is approximately 70 meters wide. It begins the entrance to the upper chamber. As the vessel enters the chamber, the 3rd and 4th tugboats are released, keeping only the tugboats ahead on the bow and aft on the stern, which will continue to assist the vessel as it completes its entrance into the chamber and through the locks. When the vessel is in the desired position inside the lock chamber, the Panama Canal line handlers, with the support of the ship's crew, secure the vessel to the center wall with the use of 4 lines that will be sent out from the vessel. The lines will be received by the lock's mooring personnel, who will secure them to the bollards on the wall. Once the vessel is secured to the wall and the gates behind are closed, the emptying of the chamber begins. As soon as the water level for the next chamber is reached, the lock gates ahead of the vessel open to allow access to the middle chamber. Once the lock gates are completely open and the lines are cast off, the vessel begins to move to the next chamber, in this case the middle chamber, using engines and rudder and the support of the tugboats. When the vessel is in position in the middle chamber, the process of mooring and moving will be repeated, and repeated once more when in the lower chamber.
The goal: to build the new locks. Wider, deeper, longer. Lock has been molded by the hands of thousands of workers. Far beyond local borders, the new gates are being built in Italy. Built of structural steel, each weighs an average of 3,300 tons.
12 have already arrived, marking the beginning of the project's electromechanical phase.
Numerous deliveries with the large elements required by the lock's filling and emptying system have arrived on site. The deliveries include a series of last-generation hydraulic valves to regulate the flow of water.
After the Panama Canal expansion is completed, the waterway will face new challenges in transit operations and procedures.